We're now going to move to Fred Wassmuth. I've known Fred for, I don't know, decades anyways, eh, Fred?
Yeah,
He's,
sounds like it.
Yeah, he's senior team lead at InnoTech in the in-situ recovery unit. He has broad background in investigating unconventional oil recovery. Lately, Fred has been focused on developing new plugging and abandonment technologies for well decommissioning. And Fred holds a PhD degree in physical chemistry from the U of C. So I'll turn it over to you, Fred. Thank you very much.
My name is Fred Wassmuth. I work for InnoTech Alberta, and I'd like to introduce our well decommissioning program today. We have several environmental programs going on, from carbon capture conversion and utilization to advanced technologies, looking at data and artificial intelligence. And then the program that I'm closely involved is energy asset retirement, where we're looking at subsurface and surface remediation of oil wells. Now, within these programs, there's a certain amount of overlap. For instance, we're trying to use the digital world in order to prioritize wells for retirement, and the carbon capture and conversion ideas could be potentially brought right to the abandonment wellbore. All right, we're located in 4 different locations within Alberta. Our mothership is in Edmonton. We have a farm facility in Vegreville, and I'm myself located here in Calgary. And I think overall we have 1 million square feet of lab space with all these different centers. The challenge and opportunity that we see within the province of Alberta is to have on the order of 90,000 active wells, inactive wells, and another 100,000 marginal wells that are soon to be slated for inactivity. From those wells, there are an estimated 40,000 leaking in Alberta, and that require either extra attention or the leaks need to be sealed during decommissioning. One thing to note, this may hit home, there are really 150 wells leaking in urban areas in Alberta. And by the urban areas, I mean the larger centers like Medicine Hat, Calgary, and Edmonton. The Alberta Energy has realized that there's quite a liability that operators face. And if you just look at the in-situ oil and gas area, the liability is accounted to about $100 million. Now, in the subsurface plugging and sealing of wells, that's the big challenge. In the past, cement has been widely used for plugging and abandonment. However, cement plugs, when tested in laboratories, found to be not as efficient as initially thought and not as long lasting. And for leaky wells, on average, it takes 3 attempts in order to stop the leaks with using regular cement slurries, which have been approved by the AR. So there's a tremendous opportunity here to come with new technologies and improve the efficiency and success ratio. And that's what we're trying to achieve. So as far as new technologies and novel sealants based on alternative materials, you have a whole range of technologies that can be tried and tested. But these technologies, most of them have not been approved for plugging abandonment of wells. Some of the new technologies that are coming up are things like magma plugs, where you set off a magma chamber by using thermite within the well bore. and the technology that we recently worked with are silicate-based sealants and resins as well, which perform in some cases better than cement. What's in it? What is the value proposition for the different entities that we're dealing with? For producers, the reduction of the $100 billion well liability for service providers. We validate alternative products, and the regulators, like the AR, appreciate working with us because we can test according to their criteria so that they feel relatively safe in improving the material for field use. And so really what we have to do is test how effective is the material, how long will it last, is it actually safe? When it comes to testing these alternative materials, we set up a qualification process, and it's quite simply, we look at the toxicology of the materials, we do basic material evaluations, then we go on to endurance testing. The material is supposed to last for up to 3,000 years. We need to do some endurance testing. From there on, we do specific function tests of casing plugs, or we test the sealants that are supposed to be applied in fissures. And once all that is passed and the AR approves field use, then we can go to field pilots and site monitoring. So we conducted several of these tests on a shoestring budget, and we repurposed existing technologies, but then with CanERIC support, we beefed up some of our capacity in the laboratories, and I'd like to talk about that right now. On the risk assessment of the alternative product, we look at the toxicology and evaluate whether the components that are in the formulation are toxic or non-toxic, or whether the final product that is generated is toxic or non-toxic. And based on that, we design preventative measures, if need be, in order to minimize the risk of contamination or leakage. And that will give some indication how widely the product can be used or what situations it can be applied. For the basic material evaluation, we look at things like the density of material and then the shrinkage or expansion of the material after setting. The materials are evaluated based on compressibility and subsequently with respect to adhesion to the casing and the amount of force it takes to dislodge them from the casing. Now, initially on the left, we bought a press from Canadian Tire, automated it, and we did our shear tests with this simple press. Now, with some CanERIC funding, we were able to upgrade our instrument, which is from the material testing group up in Edmonton, and we were able to convert this or change this apparatus so we can do our adhesion and shear tests within the computerized setup. And so yeah, that was one of the improvements that we were able to achieve with the CanERIC sword. On endurance testing, as I mentioned, the material is required to last for up to 6 months, for up to 3,000 years. And so what we do in this case is we look at long-term experiments and pressurized and temperature-controlled reactors, and we can go from moderate environments all the way to aggressive corrosive environments. On the left-hand side, it shows the equipment that we started with. It was a rocking cell that was repurposed from our PBT experiments to do these endurance tests. And on the right-hand side, we now have a modern temperature reactor that we can do these endurance tests in. On the function tests are designed to test the barrier materials under wellbore conditions, be they casing plugs or sealants to seal cement fissures or wormholes on the wellbore. For the casing plugs, we try to follow the feed protocol as much as possible. We set the abandonment plug within a casing, and then we pressure test the plug and measure the seepage of the fluids. For sealing materials, we set the sealing materials in cement fissures and subsequently also do a pressure test. On the left-hand side, when we started this, we repurposed a core flood apparatus that wasn't being used anymore. But lately, with the CanERIC support, we did buy a new rack where we can put the 2-meter-long casings or attach the 2-meter-long casings and do our phase function tests on that. So the casings have been modified so we can put end pieces on and can set up to 2-meter-long plugs in them. Well, before we strap these casings to the stairs, now we have a rack that we can use. And we can even set the cases at an angle just to test the material in deviated wells. Okay. Going to the field application, we repurposed an existing trailer. We can design the well decommissioning trials, and then we can do the quality control on the field pilots as far as mixing and applying the formulations. We geared up a little bit on the monitoring, and after today's presentation, I realized that may not have been necessary, but we managed to buy some meters from Capstone in Airdrie. We looked at 2 Alberta products, and we decided to go with Capstone because it had a long field record. And then I also, on the gas migration, I talked to Dave Risk from St. Francis Xavier University, and he suggested that we go and buy some gas flux chambers from eSense. Now, I should point out that we also have a surface remediation group, and it turns out that they also have some gas flux chambers, and we can work in with their equipment and expand our monitoring capability. But also see that several other people have trailers and can help out in that case. What have we done lately? We have confirmed our capability in conducting the tests and verifying the materials according to UK oil and gas guidelines that are, if you have a look at those guidelines, they're extensive and very thorough. So instead of reinventing the wheel, we went with guidelines. We developed some good performance-based tests, endurance tests using Alberta conditions, established communication with the AER so that they are aware of the tests we're conducting in advance, so that there is not a confusion when they see our results of how valid they are or not. We have successfully tested one product and brought it over the goal line. That was a resin-based product, and I should say that company has been quite successful applying for the stimulus package that's available through the provincial government. On deck, we have another 3 products for testing, and that is those products are being tested with CanERIC support, or CanERIC is quite aware of the tests that we're doing. In the end, we're open to collaborations. If you have ideas on new products that you want to test, or if you have some capabilities on this product testing, please talk to us. And on the field trials and monitoring, I would be pleased to involve some other groups to see how well the products work out in the field. There's my contact information, and I should also point out, if you can't get a hold of me, talk to Ilya Remchuk, who's a colleague of mine, and he's also involved in this CanERIC grant. Back to you, Larry.
Awesome. Thank you very much, Fred. That's a good project that's being developed here between OPERF's program, WORI. I saw Sean Forster was on the call here, and he's the chairman of the WORI group within OPERF. And this joint project between WORI and CanERIC is certainly leveraging the funds and getting us more testing than we could have done without it. So thank you very much, Fred. Looking forward to having these phase 1 tests done and getting on to phase 2 and then field trials with these new alternative products that should last longer than normal cement. So I'll open up the floor to anybody for questions for Fred.
Hey, Fred, this is Brian. I got a question for you. You know, I really like the slide on the statistics. It's obviously lots of wells, 90,000 with another 100,000 coming into the fold. If you were to sort of broadly categorize the challenges with abandoning wells, you know, very, very simply, what would you assign as a percentage of wells that you can simply abandon with a cement plug? Others have wormholes that you've got maybe more challenges, and then of course gas migration in sort of chops areas would be a further challenge. Is there a sort of a high level percentage you'd say of what the industry faces as far as, you know, those buckets of categories of well challenges?
Okay, so I'm going out on a limb here. I think a gut reaction would be 70 to 80% of the wells can probably be abandoned without significant issues. And I'm talking especially now conventional wells, which we're really facing. On the thermal wells for SAGD and cyclic steam injection, I'm going to reserve my opinion there because I haven't seen any sealant or necessarily plugs, although there are some new scent formulations available that may also form very good plugs in hot wells. So on the thermal wells, I'll reserve my opinion and won't go out on a limb. But for conventional wells, more likely closer to 80% of the wells can be abandoned without significant issues. However, when you go to trying to seal leaky wells, then that ratio for most companies of doing 3 applications before you can seal the well, that still applies. I know several operators have improved that success ratio, so it is possible to reduce the number of interventions.
Okay, thank you.
Does that help?
Yeah, that's great. Thank you.
Okay, thanks for the opportunity, and you can always contact me.
Thank you, Fred.